So, guys, in YouTube lecture, I told you about a few themes in UPSC Prelims paper, which often repeats. So, second such theme is crops and vegetation. So, while I was preparing for this lecture, I collected few crops which appeared in examination. So, I thought, why not use this opportunity to cover agriculture fully? So this theme 2 will be in two parts. So this is part 1, and after a few days I will post part 2. In this video I will teach you some basic crops which appear again and again, and basics of agriculture. I should not say basic, but it's the only one stop solution which you have to refer, and you can easily solve from this theme itself 3 to 4 questions. And if the pattern of 2020 prelims reappear, the number can be higher. I think in that year from agriculture itself there were more than 10 questions. So we will move slowly and cover each and every aspect of Indian agriculture. So let's begin. So before we even study crops, we should get idea of soil. So from soil itself, every year or every alternate year, questions appear. So this is the soil map of India, and here you can see there are different types of soil which Indian geography has. So we'll go one by one. All right. So first soil is alluvial soil. It is formed by rivers of by depositing sediments brought from mountains. So if you look in the map, it is there. Here, it is the alluvial soil area from Gujarat to West Bengal, and this area we call as Great Plains, and it covers the largest number of geographical area in India. All right. So let's study about few properties of alluvial soil. So it covers around 40% area, and it supports crops like wheat, rice, maize. And if we talk about aerial extent, then North Plains, Rajasthan, Gujarat, KG Delta Basin also here. And it is the most fertile form of soil. Right. And if we talk about the types, we have Khadar and Bangar. Khadar is new alluvium which gets deposited each and every year by rivers, and if when it becomes old, it becomes Bangar. It is 40% area, and it is rich in potash and poor in phosphorus. You should learn this property. And one trick is that every soil of India is poor in nitrogen. That's why we use a lot of nitrogen fertilizer, and we will see how fertilizer subsidy is given. We'll also see that in later. All right. And second type of soil is black soil. So it is formed from volcanic lava. As you know that during Cretaceous period, when Indian plate was moving towards north, it encountered lava outflow from Reunion Island, Reunion hotspot. So from the remains of that lava are used for making black soil, and it has high iron content plus humus, and that's what gives it black color. Uh, it covers most of Deccan Plateau, and it has self-plowing nature. So if we go into the concept of plowing, see, why do we even plow the field? So we plow the field to uh, increase the flow of air so that lower layers of soil get air. So the unique property of this type of soil is that it has self-flowing nature. So what happens during dry areas? It forms cracks and it opens up. So those cracks allow air to move in the soil, and that's why we say it has self-flowing capability. It is clay, deep and impermeable. It can hold a lot of water. It swells and becomes sticky when wet and shrink when dry. And this is the unique property. It retain moisture for long, which helps rain-fed crops to sustain even during dry season. So if we look at that peninsular area, it has lot of rain-fed crops. We can easily grow them. Why? Because the soil has that unique property that it can hold water, and that water is used when natural water is unavailable. All right. And the type of crops which we can grow is castor, jawar, wheat, linseed, sunflower. All right. And third type of soil is red and yellow soil. Weathering of crystalline granite and gneiss in areas of low rainfall in eastern and southern part of Deccan Plateau give rise to red and yellow soil. So if we look in the map, it is here, red and yellow soil, and it is red due to iron. So the unique property of iron is that it imparts red color. And how many what kind of crops we can grow? Wheat, rice, pulses, tobacco. And if we look at the aerial extent, then Odisha, Chhattisgarh, Ganga plains, etc. All right. And so it is that iron oxide in that red and yellow soil which imparts it red color. And the hydrated form of this soil, red soil, has yellow color. And if we look at the properties of nutrients, it is rich in iron, lime, potash, but poor in N, P, and humus. So what is N? Nitrogen. P is potash. Uh, I think it should be phosphorus. There's some typo. Okay. So it is acidic in nature, slightly acidic. And if we look at the ideal pH of soil, it is 6 to 7.5. This is the ideal pH which is required for soil, where it can sustain crops and microbes. All right. And if the pH moves beyond this range, that is 6.6 to 7.5, then it becomes alkaline. Uh, you all know that if pH increase, the acidity decrease, and if pH decrease, acidity increase. So if pH increase, the soil become alkaline. And one unique property is that it cannot retain much water because it's mostly loamy. है ना? So we need proper fertilizer and irrigation to cultivate crops. And the crops which this soil can support is cotton, wheat, rice, pulses, tobacco, and oil seeds. All right. The next form of type of soil is laterite soil. So laterite soil is found in those areas which has high humidity, high rainfall, and high temperature, and it is rich in bauxite and ferric oxide. We will see the process of laterization also. We actually will see four type of process in which soil is formed, and laterization is a process in which so suppose this is soil, and water is coming, and minerals get leached. So when only iron and aluminum oxides are remain, this soil become laterite soil. And we all know that a lot of bauxite mines, bauxite is ore of aluminum. Lot of bauxite mines are actually found in Odisha. So it is due to that laterite soil, laterization process. All right. So this soil is rich in bauxite and iron oxide. It is poor in lime, magnesia, potash, and nitrogen, and it lacks fertility. So we have to provide a lot of manure, fertilizer, irrigation to allow soil to support crops. And the type of crops which we can get is tea, coffee, rubber, coconut. And one unique property which this soil has is it is used for making building material like bricks. So that red color of brick is due to that laterite soil. All right. Uh, Laterite soils minerals. And another type of soil is forest mountain soil. So it is found in Himalayan region, Western Ghat, Eastern Ghat, and Northeast region. It is rich in humus. So why it is rich in humus? कि suppose वहाँ पे टेम्परेचर कम होता है, तो जो लीव्स शेड करती हैं, वो उनका डिसइंटीग्रेशन स्लो हो जाता है. So it actually becomes rich in humus. It is deficient in potash, phosphorus, and lime, and it requires more fertilizer to support crops. And that we usually use this soil for plantation crops like tea, coffee, spices, etc. And another type of soil is arid or desert soil, and it is found in arid and semi-arid region of Rajasthan, Punjab, Haryana, and it is sandy soil without clay. All right. So Odisha, Tamil Nadu, Kerala, this is the areas where it is also found. It is poor in organic matter. It is alkaline. So we all know alkalinity. What does it mean? कि 6 to 7.5 तो normal pH होता है, इससे ऊपर हो गया तो alkaline हो गया. And it has high calcium carbonate content. So the arid soil has a process known as calcification, and due to that calcification, we get high calcium carbonate content. It has high phosphorus also, like 10 times alluvial soils phosphorus, but it has low nitrogen. It is a property of all the soils in India. Another type of soil is peaty and marshy soil. So it is found in area of high rainfall and high humidity, like Kerala, Odisha, Bengal, Tamil Nadu coast, etc. It has high humus content, similar to mountain soil. So we will see few process of soil formation, and I want to show you a texture triangle, soil texture triangle. So soil is basically, if you look at the physical composition, it made up of clay, sand, and silt, and the relative composition of each material defines the texture. So if clay is more, then we have clay soil, and if it has a lot of sand, then sandy soil, and it has if it has silt, if it has high silt, low sand, and low clay, then we get silty loam. All right, you don't need to learn this diagram, but it just for basic understanding कि सॉइल का टेक्सचर कैसे डिफाइन होता है. तो तीन चीजें होती हैं बस, क्ले, सैंड एंड सिल्ट. ऑलराइट, and this is soil horizon. Jैसे if we go vertically in the earth surface, we will get these layers of soil. So uppermost layer is organic layer, organic horizon detritus, जहाँ पे सबसे ज्यादा ऑर्गेनिक मटेरियल पाया जाता है और वो डिकम्पोज हो रहा होता है. And below that we have surface soil or top soil, which is known as a horizon. It is topmost mineral horizon. तो जो minerals होते हैं soil के, वो इस layer में पाए जाते हैं. Then we have leaching layer, which is known as E horizon, maximum leaching zone. So what happens, कि suppose rainfall हो रही है and water percolate कर गया नीचे, तो ये वाली लेयर होती है E horizon वाली, इससे जितने भी मिनरल्स होते हैं इसको नीचे ले जाएगा. ऑलराइट, एंड वो कहाँ डिपॉजिट होंगे, वो होंगे बी होराइजन में. एंड बी होराइजन इज नोन एज एक्यूमुलेशन जोन, accumulation of clay, organic matter, and metal oxide from above. So it is also known as, E horizon is also known as alluviation zone, and B horizon is known as illuviation zone. I hope you are making running notes of this lecture. Just scribble it and make your own notes, and we will give a PDF later on. All right. So C horizon, below B horizon we have C horizon, and where we get groundwater. It is also known as substratum. It is so what is the unique property of this layer? It is poorly weathered, unconsolidated material, and which is less affected from weathering. All right. So just remember it has water. जितना भी ground water होता है वो यहीं पे मिलता है, जहाँ पे जिसको हम बोलते हैं aquifers, वो इधर ही मिलेंगे C horizon में. And R horizon में we have bedrock or parent material. All right. So now we will see soil formation processes. इसमें क्वेश्चन आ चुके हैं CDS और CAPF में, but they might ask these questions or this concept in CSE also. It is heavily asked in geoscientist paper, geoscientist prelims paper. So we will see 4 such concepts. So one is glaciation, soil formation process that takes place under waterlogged condition. So if you remember, there is one national park in Manipur where Fumdis are found, and one animal is also found which is endemic there. You can pause the video and guess the name, and that name is Sangai deer. All right. So in that national park, we have waterlogged condition, and due to waterlogged condition, there occurs anaerobic condition or oxygen deprived. So due to anaerobic condition, certain type of bacteria are born, which actually eats up iron compound from soil. And when iron compounds are completely decomposed, the color becomes gray and bluish. This is, and if you remember what color does iron has, it is red. All right. So due to waterlogged condition, we have anaerobic conditions. Oxygen gets deprived, and in those conditions, iron compounds get depleted, and color become gray and bluish color. So in glaciation, iron content decreases. Another process is laterization, and it gives rise to lateritic soil. So suppose this is we already discussed this concept. So suppose this is soil, and water comes, and water passes through soil. So it washes away silica, aluminium, calcium, and what remains is iron and aluminium, which is brick, which makes color of this soil brick red. So it occurs in hot and humid climate. So heavy leaching increases concentration of iron and aluminium oxide. So it is somewhat opposite to glaciation. It is one way to learn this or remember this. So another process is podzolization. It occurs in cold, wet climates like boreal, subarctic regions, tundra, etc. So what happens? So if this is soil, uh, calcium carbonate, iron oxide, aluminum oxide gets leached, and what remains is silica. Since silica is light, it occurs at topmost layer, and this gives rise to ash gray color. All right. So in podzolization, calcium, iron, aluminum gets leached. All right. And fourth process calcification. It is inverse of podzolization. इसमें क्या होगा कि कैल्शियम कार्बोनेट एक्यूमुलेट हो जाएगा और ये कहाँ कहाँ होता है अभी देखा था हमने एरिड और सेमी एरिड रीजन्स में राइट तो ड्राई एंड सेमी एरिड रीजन एंड देयर इज समथिंग कॉल्ड कंकड़ this is nothing but calcium carbonate and it is found in arid areas, arid area soil. So it is small stone like structure of calcium carbonate. All right, so we have covered basics of soil, and now we will later we will see some questions, and you will feel that we can solve all the questions from these simple concepts. All right, so now we will see soil degradation, alkalinity, acidity, salinity, etc. And there have been few questions from these topics, the concept of which is applied there. And all right. So soil degradation is basically when so soil is a non-renewable resource. You all know that, है ना? तो जब वो डिग्रेड होती है तो कैसे होती है? या तो इरोड हो गई या उसकी क्वालिटी खराब हो गई. क्वालिटी कैसे खराब होगी कि सैलिनिटी बढ़ गई, एल्कलिनिटी बढ़ गई, एसिडिटी बढ़ गई, ये सब चलता रहता है ना. तो इरोजन को एज अ कॉन्सेप्ट इट इज ऑफ टू टाइप्स लाइक वाटर इरोजन एंड विंड इरोजन. तो वाटर इरोजन कैसे होता है कि I'll make a diagram here. So suppose this is ground and बारिश हो रही है इस पे. तो सबसे पहले क्या होगा? रेन ड्रॉपलेट्स एक्चुअली हिट सॉइल लेयर. तो सबसे पहले क्या होगा? स्प्लैश. पानी गिरेगा तो स्प्लैश होता है ना. तो पानी गिरा और यहाँ पे एक होल सा बना देगा वो. इट विल क्रिएट अ स्मॉल होल एंड फ्रॉम दैट होल द सॉइल विल स्प्रेड आउट लाइक स्प्लैश. तो सॉइल स्प्रेड हो गया. And if this process gets intensified, then it will give rise to sheet. So when these holes are more in number, then whole sheet of topsoil gets eroded. And if sheet erosion gets intensified, then we have rills, formation of rills. Rills are small gullies. So when the mechanical strength of soil is very less or it gets surpassed by impact of rainfall, then we have gully formation. Through these channels water flows, and when these gullies get enlarged, it gives rise to ravines. All right, so we have sheet, rill, gully, ravine. All right, rills are basically small channels, and when they get enlarged, it gives rise to gully. These are small channel, and when those channel gets enlarged, it gives rise to gully. Gullies are actually few feet in length and depth, and ravine are few like 10 to 20 meters in length or depth, width, etc. And where do we actually find ravines in India? It is associated with Chambal region, and it is also known as badland topography. All right. So water erosion is of two types. One is due to rainfall, and another is due to the flow of river, which is known as bank erosion. And another type of erosion is wind erosion. It is also known as aeolian erosion, and it is prominent in arid and semi-arid areas. All right. Now we will see some problems of soil which are prominent in India. So one such problem is alkalinity or alkaline soil, which is also known as sodic soil, है ना. तो नॉर्मल पीएच हमने देखा था 6 to 7.5 होता है, एंड व्हेन पीएच बिकम्स मोर देन 8.5, so acidity is actually decreasing. We all know pH increase, acidity decrease, so it is become alkaline. And in alkaline soil there is a domination of exchangeable sodium ion, Na plus, rather than neutral salts. So in normal soil we have neutral salts. The ions do not move around, but in alkaline soil we have mobile Na plus ion, which we will see how it gets move around. So when sodium carbonate and sodium bicarbonate concentration increases, so they get broken into sodium and carbonate, and this is sodium and it is bicarbonate ion. So this Na plus has high affinity towards OH minus. So अगर थोड़ा केमिस्ट्री का आइडिया होगा तो जो जैसे सोडियम होता है, पोटेशियम होता है, तो इनके दे हैव हाई एफिनिटी टुवर्ड्स गेनिंग इलेक्ट्रॉन और टू अट्रैक्ट नेगेटिव चार्ज, है ना. तो Na प्लस OH से कंबाइन कर जाएगा एंड इट विल फॉर्म स्ट्रॉन्ग बेस. NaOH इज स्ट्रॉन्ग बेस एंड दिस इज व्हाट गिव राइज टू हाई एल्कलिनिटी. ऑलराइट. सो व्हाट आर द कैरेक्टरिस्टिक, मतलब अगर समझ नहीं आए तो बस ऐसा समझ लो कि एल्कलाइन सॉइल में एक्सचेंजेबल सोडियम आयन होता है जो स्ट्रॉन्ग बेस फॉर्म करता है और जो एल्कलिनिटी बढ़ा देता है, पीएच कम कर देता है. बस और कुछ नहीं पढ़ना, और कुछ याद नहीं रखना, है ना. मतलब यूपीएससी में पूछा जाता है, ऐसे साइंटिफिक कॉन्सेप्ट तो नहीं पूछेंगे इतना डेप्थ में. दे विल आस्क कि हाउ कैन वी एक्चुअली क्योर एल्कलिनिटी ऑफ सॉइल, है ना. सो वी विल सी हियर इन दिस स्लाइड्स कि हाउ वी कैन एक्चुअली क्योर इट. तो कैरेक्टरिस्टिक क्या है? इट हैज हाई पीएच, वी ऑल नो. It has poor soil structure. These are basic points. Low permeability and poor drainage. It becomes hard when water concentration decreases, and sticky when it becomes wet. And it has poor fertility. That's the main problem which we encounter. कि fertility कम हो जाती है, yield crop yield खराब हो जाएगी ये सब. And now we'll see कि how it actually forms. So we all know कि सोडियम कार्बोनेट या सोडियम बाइकार्बोनेट की कंसेंट्रेशन जब बढ़ेगी सॉइल में तो वो एल्कलाइन हो जाएगा. तो कैसे बढ़ सकती है? या तो वो एक्यूमुलेट कर जाए कि सॉइल फील्ड में वी हैव पुअर ड्रेनेज एंड वी आर अप्लाइंग वाटर रिच इन सोडियम कार्बोनेट एंड सोडियम बाइकार्बोनेट, एंड ड्यू टू पुअर ड्रेनेज द एक्यूमुलेशन इज हैपनिंग फॉर सोडियम कार्बोनेट एंड सोडियम बाइकार्बोनेट, पुअर ड्रेनेज कंडीशन. And one such is weathering. If parent rock has more carbonate, it is more sodium carbonate and sodium bicarbonate material, and if it gets disintegrated, weathered, so it will increase the concentration of sodium carbonate and sodium bicarbonate. And another reason is arid and semi-arid condition. So what happens? I'll explain this concept here. This concept itself has been asked in 3 questions of UPSC indirectly. Directly तो basic science में पढ़ते ही इसको. This is known as capillary action. So what happens in capillary action? So if it is suppose this is soil, and in soil we have small capillaries. So when water at the top layer gets evaporated, due to surface tension, it will suck out water from lower layers. So through these capillaries, water moves upward. So surface tension, we all know that it is due to cohesion of molecules of same kind, है ना. तो ये water ऊपर जाएगा, जब ये water ऊपर जाएगा फिर ये evaporate हो जाएगा, फिर उसके बाद जो फिर वाटर जाएगा ऊपर, वो evaporate हो जाएगा. So this cycle will continue. So what actually is happening कि when if this water or if the parent rock has more sodium carbonate or sodium bicarbonate, तो क्या हो रहा है वहाँ पे कि पानी अपने साथ ये तो ले जा रहा है, ऊपर जाके जमा कर रहा है उसको, पर खुद evaporate हो रहा है. So water is collecting sodium carbonate and sodium bicarbonate salts. They gets accumulated here, but water evaporates. So this cycle continues, and it leads to accumulation of sodium carbonate and sodium bicarbonate. And another reason is if we use sodium rich water, all right, and this we have done capillary action, sodium salt accumulation. Now we have understood the problem. Now we'll see how we can cure this problem. So it is that so the main culprit here is sodium ion. Somehow, if we can replace that sodium ion with something else, then the problem of alkalinity will vanish. So what we do is we apply gypsum. So gypsum is calcium sulfate dot 2H2. It has water molecule attached. So what does gypsum do? The calcium from gypsum replaces sodium, and sodium gets leached out. All right. So this actually decreases concentration of sodium in soil, and alkalinity decreases. Basically pH कम हो रहा है और वो एसिडिक की तरफ बढ़ रहा है फिर. All right. So another solution is proper drainage, so that salts can easily move from the field. है ना? Third solution is green manuring. Uh, there is one plant known as dhecha. It is no English name is Sesbania. So when we use this green manure in field, the dhecha, it actually decreases alkalinity. It lowers the pH. All right. And another solution can be use of canal water. So canal water has low sodium. If that's the case, then we can replace it with groundwater. We can replace groundwater with canal water, and to decrease the sodium concentration in soil. All right. So you should learn this gypsum, the use of gypsum, क्योंकि ये क्वेश्चन 2 बार आ चुका है gypsum का, है ना. Second such problem is soil salinity. So what happens in soil salinity? We have high concentration of soluble salts, but pH is actually below 8.5. So pH की problem नहीं है इसमें. All right. यहाँ पे problem है salt concentration बहुत high हो गया है. और salt कौन से होते हैं? Salt होंगे सोडियम क्लोराइड, सोडियम सल्फेट, कैल्शियम क्लोराइड, कैल्शियम सल्फेट, मैग्नीशियम क्लोराइड, मैग्नीशियम सल्फेट. तो जो कैल्शियम सोडियम एंड मैग्नीशियम के क्लोराइड्स हैं और उनके सल्फेट्स हैं. बस इतना ज़्यादा रटना नहीं है, बस आइडिया है बस. And how we actually measure soil salinity? We measure it with a device, and what the device does is it measures electrical conductivity. So if electrical conductivity is high above a certain limit, then we call soil saline. All right. So characteristic क्या होते हैं? एक पिक्चर बहुत फेमस हुई थी बीच में ना, कि पंजाब के जो फील्ड होते थे वो उन पे व्हाइट लेयर बन जाती थी ऊपर, एंड दैट व्हाइट लेयर, व्हाइट क्रस्ट इज ड्यू टू सैलिनिटी, है ना. सो कैरेक्टरिस्टिक यही है कि व्हाइट क्रस्ट ऑफ सॉल्ट ऑन सॉइल सरफेस, नॉर्मल टू स्लाइटली अल्कलाइन पीएच लेस देन 8.5, एंड पुअर क्रॉप ग्रोथ, है ना. और फॉर्म कैसे होता है? जो अभी सोडियम वाला कॉन्सेप्ट था, को कैपिलरी एक्शन वाला सेम कॉन्सेप्ट इज यूज्ड हियर. If we have high evaporation rate, the salt from lower layers gets accumulated in the top layers and water gets evaporated. So this cycle continues, you know. And it is more prominent in arid and semi-arid climate where rainfall is less and temperature is high. So it actually intensifies the evaporation rate. And another is poor drainage and seawater intrusion. Suppose in coastal regions, when if seawater gets intruded into the fields, है ना, तो वहाँ पे salinity बढ़ जाएगी. And another reason is weathering of salt rich rocks. If primary rock is salt rich naturally, then it will increase the salinity of the soil. All right. So what is the solution of salinity? कि salinity कैसे decrease कर सकते हैं? तो salinity decrease करने का सीधा फंडा होता है कि जो टॉप लेयर है ना उसको रिमूव कर दो, क्योंकि वहां पे सॉल्ट कंसंट्रेशन ज्यादा है. So if we remove the top layer, the net salt concentration in the soil gets reduced, and if we enhance the drainage capability of the field, then also salt concentration will decrease. So we have a solution like removing top layer, breaking salt pans which are formed on the top layer. I hope you are writing all these points, you know. And enhancing drainage of field, or another can be using fresh water. Fresh water here means water having less salt. Okay. Another problem is soil acidity. So it is not very common, but there has been a question on soil acidity, so I thought of covering it here. So soil acidity means the normal is 6 to 7.5 pH. So if soil pH reduces below 6, then we will call it acidic soil. So there are few regions in India where this problem is very prominent, like humid regions of southwestern India, northeastern, and Himalayan regions. Right. Uh, Reason can be there are many reasons. Like if we apply more ammonia fertilizer, it will increase the natural acidity of the soil. This is written here. High levels of ammonia-based nitrogen fertilizer and harvesting plant materials. So what happens is, so if soil has a plant cover, so plant cover actually imparts alkalinity to the soil, and if we remove that plant cover or plant material, the source which was providing alkalinity to the soil gets removed and it becomes acidic. All right. So plant material was having neutralizing effect, and when it gets removed, it becomes the soil becomes acidic. इम्पैक्ट इज सेम लाइक डिप्लीट्स फर्टिलिटी वगैरह जो हमने ऊपर पढ़े थे, पर एक यूनिक थोड़ा पॉइंट है कि ये इनऑर्गेनिक कार्बन जो होती है सॉइल की, ये इसको भी डिप्लीट कर देता है ना? तो उससे क्या होगा कि सॉइल की फर्टिलिटी खराब हो जाती है. इनऑर्गेनिक कार्बन क्या होता है? द कार्बन विच वी गेट फ्रॉम ओर्स एंड मिनरल्स. एंड व्हाट इज ऑर्गेनिक कार्बन? द कार्बन फ्रॉम प्लांट्स एंड एनिमल्स. राइट. जैसे एनिमल डंक हो गया, एनिमल डेड रिमेन्स हो गया, तो उसके डिसइंटीग्रेशन जो कार्बन आता है उसको ऑर्गेनिक कार्बन बोलते हैं. So the solution to cure soil acidity is applying dolomite. So if we apply dolomite, the acidity will decrease, the pH will rise. All right. So we have covered some basic concepts. Now we will see cropping patterns. क्योंकि इस पे क्वेश्चन आ चुके हैं और इसमें ना थोड़ा सा मतलब कंफ्यूजन होती है लोगों को कि भाई मिक्स्ड क्रॉपिंग, मिक्स फार्मिंग में क्या डिफरेंस है ना? इंटरक्रॉपिंग, सिक्वेंशियल और रिले क्रॉपिंग में क्या होता है, रटून क्रॉपिंग क्या होता है, ऐसे ये छोटे छोटे कॉन्सेप्ट्स हैं और इसमें सब कवर हो जाएंगे. तो प्रीलिम्स के लिए ना ज़्यादा कुछ ऐसे पढ़ना नहीं होता, बस पिन पॉइंटेड सी चीज़ें हैं जो पढ़नी होती हैं, और अगर कॉन्सेप्ट अच्छे हैं तो आराम से 120 प्लस आ जाते हैं. इन 23 आई गॉट एंड व्हेन कट ऑफ वाज 75. सो दीज आर माय सिंपल नोट्स एंड आई हैव बाय हार्ट लर्न देम. एंड बस इसमें ही पढ़ते रहो इनको नोट्स को, और क्वेश्चन इनकी एप्लीकेशन ही क्वेश्चन में होती है. अब ऐसा नहीं है कि इफ यू विल लर्न दीज नोट्स देन क्वेश्चन डायरेक्टली विल कम फ्रॉम देम. You have to actually internalize them, internalize the concept, so that you can easily apply them in prelims paper. All right. So agriculture is a term, it is a broad term which actually include everything like crop production, livestock, farming हो गया, fishery, forestry, etc. है ना? तो we have different types of cropping patterns, like how crops are मतलब crop कैसे, how crops are distributed along space and time. All right. कि उससे फिर क्रॉपिंग पैटर्न आता है. तो क्रॉपिंग पैटर्न कैसे होता है कि वन सिंपल सच इन मोनोक्रॉपिंग. इन अ फील्ड, सपोज दिस इज अ फील्ड, यू प्लांट वन क्रॉप, हार्वेस्ट इट, अगेन प्लांट सेम क्रॉप, हार्वेस्ट इट, दैट्स इट. This is monocropping, and it is actually bad for environment. Why? Because these crops have low immunity to plant or pest attacks and pathogen attacks, so they are very vulnerable. All right. And another type is multiple cropping, where we actually grow multiple crops at different times, so at same time, at in different areas of a same field, at same area, etc. So let's learn that. Monocropping is only one crop is grown on farmland year after year, and multiple cropping is of many types, like mixed cropping. So mixed cropping में क्या हो रहा है ना कि two or more crops are grown all at the same time. मतलब यहाँ same time keyword है in a field. तो इसका फायदा क्या होता है ना कि अगर if somehow one crops get failed or it has poor yield, it get other crop will compensate. So farmer has a cushion to rely. All right. Another type is strip farming. Strip farming में क्या होता है कि suppose this is a field, we will plant main crop in line, in rows, and to fill the remaining space we will plant another crop. That's it. It is strip farming. And what is intercropping? When two or more crops are grown at the same time with definite row arrangement on the same field. तो इसमें क्या है ना कि स्ट्रिप फार्मिंग और इंटरक्रॉपिंग में डिफरेंस ये कि द मेन फंडा बिहाइंड सेकेंडरी क्रॉप वाज टू फिल द स्पेस. That's it. So why do we need to fill the space? so that the soil, we have to maintain constant soil cover so that it does not get eroded. Like we learned in the wind erosion case कि अगर विंड की स्पीड ज्यादा होगी तो वो इरोड हो जाएगा, है ना? तो बस उसको कवर करने के लिए क्रॉप कवर ही है, राइट? इंटरक्रॉपिंग में क्या होता है ना कि इसमें एक फंडा होता है कि क्रॉप्स नीड टू कॉम्प्लीमेंट ईच अदर. सपोज इफ आई ग्रो कार्ब रिच cereal here in one row, then in another row I will plant legume. So why? Because carb rich cereal has a property that it will use nitrogen from the soil. All right. So to refill that nitrogen, to refill the fertility, to maintain the fertility of the soil, I will plant legume that will actually fix nitrogen. In later slides, we will learn how nitrogen gets fixed. The nitrogen cycle as a whole concept I will teach in environment, but यहाँ पे थोड़ा देखेंगे कि बायो फर्टिलाइजर एक कॉन्सेप्ट है, एक टॉपिक है, वो देखेंगे उसमें क्या होता है, राइट? सो अनदर इज सीक्वेंस क्रॉपिंग. तो सीक्वेंस क्रॉपिंग में क्या है ना कि सपोज दिस इज time axis. So I will grow one crop, I will harvest it here. Then after harvesting, I will plant another crop. So this is crop 1, this is crop 2. So they are in a sequence. When crop 1 gets harvested, then only I will plant crop 2. In relay, what we do is, even before harvesting one crop, so this is first crop, we will plant. So the timeline of second crop will start before. So this is where timeline of second crop will start, and this is actually before the harvesting of first crop, है ना? So example can be maize. Maize is first crop, and before we even harvest maize, we plant beans. So why we actually do it relay cropping is because some crops require shade to grow, or we can say nurse crop. So maize is a nurse crop for beans. All right, and this is known as relay cropping. And another is alley cropping. So alley cropping में क्या होता है ना कि we will plant crop in rows, and in the spaces between rows we will plant trees. This is also known as agroforestry. So we are doing agriculture and forest activity on the same field simultaneously. So what is the advantage of this? Advantage is sometimes these tree act as windbreaks. They protect the crop from wind, high velocity wind. And another advantage is it is a supplementary income source for the farmer, right? So somehow if crop gets failed, then farmer can cut these trees and sell the timber. All right. Now we will see a few questions which have been asked in UPSC, and we will try to learn few concepts from those questions. It is like reverse engineering.